Welcome to PDA Learning Byte, a unique online collection of online learning in bite-sized pieces.
Welcome to PDA Learning Bytes. My name is John, and in today's Learning Byte, we're going to look at a strategy for solving multiplication problems known as duplation. Now, what I love about duplation is that it opens the door for second grade teachers to give students a strong conceptual foundation for multiplication in a way that A, allows them to continue having their students practice the addition of several multi-digit numbers, B, does not require students to have any exposure to the multiplication table or to the common multiplication algorithm, C, strengthens their ability to model story problems, and D, deepens their conceptual understanding of multiplication before it has even been formally introduced. For duplation to have the most impact, you'll want to guide students in developing the strategy themselves rather than going straight into the formal process. Let's look at a word problem that you might use to get the process started. The students at a school are lined up in the gym for a group picture. There are 45 rows of students, each of which has 31 students. How many students are there in all? Don't let the large numbers scare you. By the last half of second grade, students are very comfortable with two-digit numbers, and using large numbers will force students to search for problem-solving strategies rather than simply counting. To get students started on solving this problem, you may want to give them a handout that shows a 45 by 31 array and ask them to develop strategies for finding the total amount of objects within the array. Students may develop several great strategies, and allowing them to explain these strategies to you and to each other will strengthen their ability to communicate mathematical ideas. After your students have had an opportunity to develop their own strategies for solving the problem, you'll want to start guiding them toward duplation. To do that, the first question you'll want to ask them is, how many students would be in the first row of students? They'll pretty easily be able to tell you that one row will have 31 students in it. Then ask them, well, how many students would be in two rows? And it will be pretty easy for them to tell you that there are going to be 62 students in that two rows. Then you'll ask them, well, how many would be in four rows? At that point, they hopefully will realize that they can simply double the amount in two rows to tell you that in four rows, we would have 62 plus 62, or 124 students in four rows. Then ask them how many would be in 8 rows, and they'll start to sense the pattern. 8 rows has 248 students. 16 rows would have 496 students in it. And lastly, 32 rows would have 992 students. So as students are working through this, they're getting an opportunity to practice their addition of multi-digit numbers. We're going to stop at 32 because we don't have 64 rows of students. We only had 45 rows of students. So 64 is not going to give us any useful information. Then you could say, okay, we want to find out how many students are in all 45 rows. Well, let's start out by taking out 32 of those rows, which is a relatively large chunk. So in 32 of those rows, we had 992 students. Well, how many rows does that leave us with? Well, if we had 45 rows and we're taking out 32, that leaves us with 13 rows. Let's take a closer look. So if we take out 32 of our rows, we're left with 13 rows. Well, what if we took another 8 out of that 13? We know that 8 rows has 248 students in it. So we know that so far we have 992 students plus 248 students with another 5 rows that we've not yet accounted for. So out of those 5 rows, we could pull out 4 rows, in which point we would have 124 additional students, And then in the last row, we would have 31 students. After students have had several opportunities to solve problems informally using duplation, you want to help them to formalize the process. Duplation is normally written with a T-chart. So for the example that we used, we had 45 rows with 31 students in each row. The way that this works is to first write a 1 on the left-hand side, and then to reproduce the 31 on the right-hand side. We will then double for each successive row. So if we double 1, we have 2. If we double 31, we will have 62. Doubling 2 will give us 4. And doubling 62 will give us 124. If we double the 4, we will have 8. Doubling 124 will give us 248. Doubling 8 will give us 16. Doubling the 248 will be 496. And lastly, doubling 16 will give us the 32. And doubling 496 will give us 992. You will then be asking students, and you can point back to the chart that you used earlier, how can I add these numbers up to get the 45 rows that I was looking for? Well, you'll start at the bottom, and you can pull 32 rows out of 45, so we're going to mark the 32. Okay, if we take out 32 rows from 45, that leaves us with 13 rows left. We can't pull a 16 out of 13, but we can pull an 8 out of 13. So we're going to mark that. We'll pull 8 out of the 13, that leaves us with 5. We can pull a 4 out of a 5, and that leaves us with 1. So we'll take the 1. That indicates the numbers that you'll want to add. We'll want to add 31 plus 124 plus 248 plus 992, and that again will give us our solution. Thank you for joining us for today's Learning Byte to learn more about duplation. If you have success with this strategy, please feel free to drop me a line. Otherwise, we'll just see you next time.
We hope you enjoyed this edition of PDA Learning Bytes. Be sure to visit www.pdaonline.org for more great learning bytes and a wide variety of extraordinary professional development opportunities.